Thanks, Kavita, for your introduction. Good morning, everyone. Thanks for joining into our meeting in spite of a Sunday morning. So let's make it interactive as much as possible. So let me share my screen. Okay, so I'll be giving you an overview of what is DevSecOps and in the pipeline, how you can secure your pipeline to find the vulnerabilities. So the today's agenda is going to be this is a high level of myself. So having experience in application security, source code, and mobile security, and completed various certifications. I've been an active speaker in L Chennai and OS Chennai, and I've been a project advisor for many colleges. So this is going to be our agenda for today. So what is DevSecOps? So what is the process flow we have, and how we are going to make integration with the DevOps, and what are the various challenges we have in the CI/CD pipeline, and what are the various automation tools we are going to use for securing our CI/CD pipeline. And we need to know like what is the software supply chain. That's the trending topic now from a developer's perspective, how you use your software supply chain, various vulnerabilities happen, and how your applications can get hacked, and the real attack scenarios, and what are the best practices you have, and what are the emerging players in the market who supports a variety of tools. Okay, so before we go in, right? So let's take an example. Um, you have an application, you want to build an application, so what you logically will do, so it will be variety of steps will be there. So starting, if you're in previously like 10 years before, there was a model called waterfall model. So you get the requirements from the customer, you baseline it, and then you do the design, and then you move into the coding phase, and then after coding is completed, then only it will be moved into the testing phase, and then it moves into the production. This is called a waterfall model. But now, in the last 5 years or so, all companies are moving with a model called as the agile model. So the entire product will be divided into multiple sprints. It depends on company to company. Maybe like first, some companies have 4 week sprints or 2 week sprints. Sprint is nothing but a small phase wherein the development testing team, all team join together and perform that particular release and complete it as early as possible. Okay, before I start off this session, whatever the session I am giving today, it's purely based on my knowledge and experience. It is not representing my company, or it is not affecting any of my vendors as well. So this is purely a knowledge from my perspective. This is a disclaimer from my end. Okay, any questions you have in the middle, you can interrupt in the middle, and you don't understand even a single word, you can jump in and ask, because from a participant perspective, any small question is a good question. Okay, I'll move on with the session now. So this is the concept called as the shift left security approach, has been started in the last 2 to 5 years. So due to this agile methodology. So previously, like after you finish the development, then only it goes into the testing team. They find the vulnerabilities or issues, and then the cost of fixing the defect is always very high. Whereas because of the concept called shift left approach, even in the design phase itself, the security consultant plays a very important role. So once he gets a particular flow, he needs to understand what are the various threat cases can happen in the design itself, and then it moves into the development. And in the development also, lots of tools are being used by various companies to identify the vulnerabilities, and then it moves into the testing. So when it moves into the testing, most of the vulnerabilities or threat cases have been identified in the initial phase itself, so it becomes much easier for the teams to fix the issues as early as possible. So this is how it goes. So because of this, what happens is, okay, let's make it a little bit more interactive. Okay, so for example, you start from your home and go to your office. Okay, what are the various threats can happen? I'm just pausing here for a minute. Maybe participants, you people can say, even if it's correct or wrong, you can say. So I'm just trying to pull your legs, guys. So to make it a little bit more interactive, when you start from your home, okay, and reach your office, what are the threats do you think it can happen? Anything? Okay, I can give you an example. When you start from your home and reach your office, there are a variety of things can happen. Suddenly, rain can come in, floods can come, or a little bit traffic jam can happen. Yeah, correct. Thanks, Krishna, for your answer. Traffic. So traffic can happen, or a huge rain can happen, sudden rain, and in metropolitan cities nowadays, flooding has become a common feature now. Or your vehicle can get puncture, or your vehicle get breakdown. So there are a variety of factors. So these are the risks happen when you start from your home and reach your office. This is a normal use case scenario. The same way it happens in the source code as well. When you do your coding, that's the reason shift left came into the picture. During your design phase itself, you are going to say, okay, if it's a login page, okay, what all threats can happen? Okay, brute forcing can happen, or the hacker can enter into the application as well. So that's the reason we put in lots of controls in the uh, login page. Either it can be a two-factor authentication, or kind of an images we give it, select the images, or any kind of controls, or any kind of WAF we put into picture. So wherein by lots of requests coming in within a span of 10-20 seconds, we try to block those IP addresses. So these are the various things which happen and the various controls we put in. And maybe like in login page, we can think the other way around. In the forgot password page, what all we do, or whatever we try to do, we try to implement lots of controls. And maybe like when you log in with your username and password, okay, more than 3 times, we try to lock it. Or sometimes concurrent session authentication also we stop it, or session hijacking or session fixation we try to stop it. So these are the various things. As a application security perspective or a DevSecOps consultant, you need to be aware of, okay, these are the things need to be available in your source code and in your controls. Any questions? Okay, thank you. Okay, so I thought like to make it a little bit interactive to pull in your questions here. Okay,
Yeah,
Devan,
time
are
gone.
these threats? Yeah, the people who are not speaking can go on mute, please. Thank you. Okay, there was a question from Devanand. Let me take that question. Are these threats identified based on the OWASP model? Yeah, correct. So when we do a threat modeling, right? So there is a concept called stride model. So that is all part of the OWASP only. So stride is spoofing, tampering, repudiation, so and all those stuff. So based on these, the threats are being identified. So it varies from company to company. So during a design phase itself, the security consultant have to say all these threat cases for a specific uh, screen or a particular use case. They have to say all these cases and prepare a document and send it across to the dev team. So dev team, before they start with the design, they should consider all these parameters and they have to perform a high level design. So what happens? Developers know, okay, they have a screen and 5 functionalities to be finished. Apart from that, they need to even take the security requirements also and finish it. So then it becomes a good product to be created in the starting phase itself. That is the concept called uh, privacy by design. It has started in the design phase itself. Okay, thanks Devanand and Krishna for your responses. Any more questions from anyone you have in your mind? So which
Are
you
you
thought of
sharing your
asking?
screen?
Oh
Couldn't
yeah,
see.
yeah, sure. Yeah, I'll share my screen again. So these are the various. Okay, let me make it as a slideshow. So these are the pointers which I was saying. Shift left security approach. And the third point is automation of security testing. So in the CI/CD pipelines, we try to pull in all the tools. So maybe in the next slides, I will tell you what are the tools we are going to use in the automation of the security testing, either you identify the vulnerabilities in the source code level or in the dynamic level based on the request and the response. So the variety of tools I slides. And the fourth point is, how do you do a collaboration between the development, security, and operations team? So that plays a very important role, because previously, like 10 years before, it would be like just development folks doing on their own, and at that time the security team was very very minimal, and the operations team like that. So now it came into the concept of DevOps, so the collaboration of all these put together. So whatever I speak, right, when you see in a diagram, it becomes much easier for you to interpret it and think about it. So let me walk through with this diagram. So during your design phase, you have this DevOps. You do all your planning with whatever tools you have, Jira or anything, and then you do your coding in any of your IDEs and check in your code into the IDEs or any one of the repositories as well. So this area is called as the DevOps. Planning and coding comes into the DevOps. And then obviously once you finish your coding, it needs a kind of a unit testing have to be done. So you have to do a unit testing, and then you have to build your code using Maven or any popular tools available in the market. It becomes a continuous integration. So this is for a sprint. Let's assume you plan, and then you do your coding, and then you do your testing, and then you do your build. So it's purely comes into one agile, and then you release it into the production. So once you release, it goes into the deployment. So this area is called as the agile development, wherein for each and every sprint we do it. Okay, I'll pause here for a minute. Any specific questions related to this diagram we can ask now? Okay, thanks. I'll move on with the next slide. Okay, this slide is purely showing you, like, in each and every stage, what are the various tools available in the market and how it is being used for a DevOps integration. In planning, you have to do lots of planning. It varies from company to company. Some people use Jira, some people use JIT for the planning. And code also, like, some people use GitHub, GitLab to store their code and push into it. And then you obviously have to build your code. You have to build your code that you can use Maven or Gradle or any tools which is comfortable for that particular team, any open source tools which is available in the market. Once you build, you have to do one testing, unit testing. Either you can use Selenium or JUnit. You do all your testing, and then once you finish with the testing, it needs to go into the deployment phase. So deployment also, you have a variety of tools, Puppet, Chef, and all those stuff, and Ansible also. And during deploy and operate, you use these tools, and then you have to monitor it. Whatever happens needs to be monitored. A variety of monitoring tools you have. It can be Negios, Sensu, like this. So once you finish for one agile sprint, again it moves, like, from monitor, it again goes into the plan. Any specific vulnerabilities, they have to fix it in the next sprint itself. So this how it keeps moving: plan, code, build, and test, integrate it, and then again moves via the blue line, moves into deployment, operation, and monitor. Again via the yellow line, it goes into the initial phase. So this is how it goes as a cycle. Keep on moving with whatever operations you can do. So maybe, like, I will say, the last 2 to 5 years, most of the companies have moved into DevOps and DevSecOps. The reason is, in each and every build, you do all your operations and make sure the process is completed in a much faster pace. You identify the issues or vulnerabilities early in the life cycle instead of developing for 3 to 6 months and then going for a release, and you find all those vulnerabilities. Logically, the cost of fixing vulnerabilities is going to increase a lot. Okay, I'll pause here for a minute. Any specific questions here and there? Maybe you want to know, like, what is DevOps, or you had some queries in your mind, how it can be implemented, or any open source tools. I'll pause here for a minute.
Maybe one question from my side. This is Mohan here. There is an array of tools that you are showing here, right?
Yeah.
Is there any emerging platform or yeah, an ensemble of tools that supports the complete DevSecOps or the complete cycle, covering the functionalities of all these tools that's emerging or already in place? Just curious to know.
Yeah, sure. Maybe like you can logically use in GitHub, they have given the entire flow. Okay, you can store your code there, and they have a build pipeline also there in GitHub. It has both open source as well as commercial. So you can store your code, you can use it as a repository, and then build it over there. And then it has plugins with Jira as well, and then it has open source tools called these are open source tools called Zap Proxy. If you use it, it finds the identifies the vulnerabilities. You can plug in inside your GitLab itself. And for SAST, you have a tool called SemGrep, which I have in my last slide. SemGrep. These tools can be implemented inside your GitHub itself, GitHub and GitLab pipeline itself. It will be very useful for any team to integrate it.
Thank you.
Okay, thanks, Mohan, for your question. Okay, we'll move on with the next question, which is the various security challenges happening in the CI/CD pipeline.
Sorry, Pradeep.
Yeah, go ahead.
Yeah, I have asked this question. Can you just give me a sum up of like difference between DevOps and DevSecOps? Just a
Okay,
summary, like
great.
in two, three.
Yeah, good, good, good. Okay, it's an excellent question. So DevOps is logically okay. I will say like 3 years before DevOps came in. Okay, so in that like you do only the operations activity and development alone. Okay, so in this diagram, if you see, it is purely a kind of a DevOps only. But if you're going to implement the concept of security or plugin tools for security, then it becomes a DevSecOps. Implementing the security into the DevOps pipeline, it becomes DevSecOps. For example, there is a customer, they don't have a security team at all. Okay, so some most of the product startups I know, they only have 2 3 developers or 2 3 architects. So they will have a own pipeline and they do it. Okay, so I did VAPT for a particular customer. So in that, they did not have a security at all. So they had a planning, they written the code, they tested, unit tested it, and they released it. And then after I did an analysis, I said, okay, security is missing in their pipeline. And then I have given them suggestions wherein you can implement the security. So implement the security in the sense. So in the pipeline itself, as I've said, there are open source tools. So this is an open source tool, Zap Proxy. I've asked them to implement in their pipeline. And then there is open source plugin called SemGrep, which identifies the vulnerabilities in the static code. And they had source code in AWS and various HashiCorp and some kind of pipelines as well. I have asked them to implement this particular plugin also kicks this identifying the vulnerabilities in the infrastructure level. So if you're going to implement the security into the DevOps, it becomes the DevSecOps. It answered your question?
Yes, Pradeep.
Okay, thanks.
Thank you.
Okay. So in this way, like as much as possible, we implement the utilities and tools in the pipeline. It makes the life simpler. So I will take some 2 3 examples as security challenges here. So the most popular vulnerabilities happens is the third party dependencies. So when I reviewed a VAPT for a particular customer, they had lots of vulnerabilities in the third party. So third party in the sense like they develop a source code. So they have written all the first party component. The third party component is like either Spring Boot or anything interaction. Suppose they are doing some kind of XML operations, they use some XML component. So when they use these third party components, what happens is they have a version called 2.0. They try to implement in their source code and they push into the production. And after 2 months, what happens is the plugin which they used is vulnerable. So it is the responsibility of the dev team to always check for the third party dependencies like every weekly. So there are lots of plugins wherein it will identify in OS there is a plugin called dependency checker. Okay, dependency checker. Let me type it in the chat. It will be useful for every one of you. So if they use this plugin, okay, so obviously it will say you what are the various vulnerabilities happens in your third party. And the second point, misconfigured infrastructure as a code. This also I have a plugin which I have said you is Kicks. This one from checkmarks, there is an open source plugin called Kicks, keeping infrastructure as code secure. When you add this plugin inside your pipeline, definitely I'm telling you it will identify all the vulnerabilities in your pipeline, like anything in the Ansible, Terraform, it identifies. So, and you can find your vulnerabilities as early as possible as well. And secrets management is very, very important. So many organizations, what they do is they put all the secrets into the GitHub and they think that it is safe. No, they should not put into the, they should put into some kind of uh, password management system, kind of HashiCorp, or any kind of the walls they have to put into it. So it can lead to the vulnerabilities as well. And inconsistent patch management is always known for a longer period of time. So whatever the components or whatever the tools, softwares you use, you have to do a patch management then and there. And I can give you one more plugin in GitHub. You have a small plugin called as it is used for real-time security monitoring. That also, if you put into your pipeline, it is going to monitor a pipeline as well. And container security plays a very important role now because all the applications are moving from the in-house to the cloud. So you have a variety of containers. So containers also, the vulnerabilities have to be identified. So for container security, also you have a variety of tools, maybe Docker, Aquasec. These actually have plugins as well, which you put into your pipeline as well. So the more the plugins you put into your pipeline, it identifies in an automated fashion. Okay, I'll pause here for a minute. Any specific questions we can ask now? Okay, thanks. I'll move on with the next slide. So these are the various automation tools used for securing your CI/CD pipeline. Maybe you people can take a snapshot. It might be useful for you. Let me go to the previous slide. So in each and every area, okay, so you do your source code, you have to find that is called SAST, okay, static application security testing. So based on the request and the response, we find the vulnerabilities that is called DAST, dynamic application security testing. That is also identifies the vulnerabilities. And obviously container security, which I said when it is moved into the cloud, you have to find the vulnerabilities. And this is like infrastructure as control, wherein as I've said, there is a plugin called Kicks which identifies a vulnerability in your Terraform and all those stuff. And secrets is a very, very important. Many bug bounties are trying to find the vulnerabilities in the secrets area, wherein many people store their many important credentials or API keys in their source code itself. So one of the best practices I would used to say, don't store your credentials or API keys or any secrets inside your GitHub itself. It needs to be stored in some kind of a vault wherein it is always protected. And this is a CI/CD pipeline. You can use the GitLab pipeline or Circle CI based on your cost. So if you want to do an open source, you always use an open source. If you're going to be a banking and financial domain, you always go in for a commercial tools. Okay, so I'll move on with the next slide with SDLC and SSDLC. I'll pause here for a minute. Any specific questions you can shoot now. Okay, thank you. I'll move on to the next slide. This is logically like everyone knows it, so it's just a refresher. So, what is SDLC and what is secure? So, like 10 years before, it was logically said as the software development life cycle. But now, in the last 2 to 3 years, wherever you go, whichever meetings you go, sessions you go, workshops you go, it's always moved into the secure software development life cycle. So, that's what I say the security consultant plays a very important role in each phase of your life cycle. So maybe starting in this diagram, I can say starting with the design phase, the security consultant have to design all your threat cases. And then during your static phase, even though the plugins are installed, so some miss will be there. You can find the vulnerabilities in the static phase itself. And then it comes in the design phase. After development, it comes in the testing phase, wherein the consultant will find the vulnerabilities from a DAST perspective, which I've said, the dynamic application security testing. He finds the vulnerabilities based on your request and the response. Let's take an example. You have Amazon app. So you, for painting the data, it comes a request. Whatever www.amazon.com request goes to the server and gets the response from the server and paints into your application. Based on this request and the response, we can find the vulnerabilities. And nowadays, like the AI is becoming more popular. So I can say like yesterday I was in a debate in a MOP Vaishnav College, AI as a double-edged sword. So in that there were lots of questions asked on this AI front. So wherein like you are using lots of LLMs. So in the LLMs also lots of vulnerabilities can happen. The major vulnerability which can happen is a prompt injection vulnerability. So even though you're going to use the open source component and you build an AI or implement it, so you have to include your security consultant there and try to find the vulnerabilities in an out of box perspective and try to find as much as possible in your LLMs as well. So nowadays, one exact vulnerability I can say is the prompt injection, and another one is the data which is fed into the LLM. If it is wrong, the output is also wrong. So whatever data we try to get from the LLM or any chat GPT or Gemini, we need to do an analysis. So whether the data is correct or wrong. These are the things which you have to do it. So, and once you moved into the testing and then deployment, again you have to check, okay, whether all the controls are correct when you move into the configuration phase as well. And then again it can be a requirements phase. Again it is like a cycle, it keeps moving on. So this is one of the concept, maybe RASP. It's a kind of in production. In production, it's a kind of a agent. Okay, so it has been added. It's a kind of a WAF, I will say. So many of the companies have started using this now, wherein it detects and protects as well. If any vulnerabilities comes in, zero-day vulnerabilities, it detects it and protects it. So this particular tool is actually useful. It is from a vendor called Imperva. This is called as runtime application security protection. Okay, I'll pause here for a minute. Any specific questions?
All good.
Okay, thank you. Okay, let me check in chat. Any specific questions came in? Okay. Any specific questions? Maybe like you can put into the chat. Maybe at the end of the session, I can answer it. Okay, we are moving into the slide number 10. So this is nothing but the introduction into the software supply chain. So the when you see it in the diagrammatic perspective, what is the traditional supply chain happening in a supply chain market? How it happens? So the same thing is correlated with the software supply chain. You have lots of source and dependencies. Using it, you build your source code. You build it. So once you build it, so you build your source code. So once the source code is ready, you have all your system engineers or software engineers who develop all the source code. And then it moves via the network, it moves into it. And go to the previous slide. Okay, and then all the source code will be moved into the repository. Okay, so it can be a GitHub or a GitLab, or sometimes some companies use lots of variety of repositories like in Artifactory or any other repositories wherein the apart from the source code, the built source code binaries will be pushed into the repositories as well. And then it will be deployed into the environments. If it's going to be the cloud, it will be deployed in any one of the environments which the company is aware of. So any one of the clouds, it can be AWS, Azure, or Oracle as well. So any one of this. So this is how the interaction to the, you need to know what happens in a software supply chain. So maybe like lots of loopholes can happen in a company if the controls are not in place. They have dependencies, it is not popularly updated, or they need to have a repository wherein, okay, you have 100 open source components, whether it is updated on a weekly basis or a once in a fortnight. So maybe like some companies have even tool for that. It's a kind of a software lifecycle management tools. I can say one such tool is Nexus IQ. And till yesterday, let's assume a component is there. Let's assume it is a Spring security component. Till yesterday, it was good, but today it become vulnerable. So this software end lifecycle management, lifecycle management tool will logically say you, hey, it has become vulnerable. So and then immediately it's up to the dev team like how fast they upgrade to the latest version, and then they perform a build and push it into the production. So this is how the software supply chain happens. I'll move on to the next slide. So this is also like how do you understand the software supply chain vulnerabilities? So any kind of weakness or vulnerabilities or flaws which exist within the processes or tools it involved in developing, integrating, and delivering the software can be always exploited by the attackers. If the I will say like good developers and a good hacker and an ethical hacker versus the bad hacker or scammers will always be much more faster than us. It always says, okay, if you take the ransomware attack, mm, it always happens. So it is up to like the auditors to find it out. Okay, what are the various controls missing, and we need to know like, okay, this control is missing, and what are the patching have to be done on a regular basis. In the same way, it comes for the software development. The developers have to be a little bit cautious, and the security consultant always needs to identify the vulnerabilities at the as early stages as possible. So the vulnerabilities always can lead to a breach, which leads to distribution of compromised software to the downstream customers. So vulnerabilities can emerge at any stage of the SDLC, and it relies on the external vendors as well and contractors. So that's the reason we always have a third-party risk management, wherein like we have lots of vendors. Most of the companies will have a core team, and they would have given the testing team to the external vendors, or even the development team partial can be given to the external vendors. So we should always ask the questions and make sure all the vendors follows the process effectively. So this is how it happens when you have a source code in the image. So it logically have various source code vulnerabilities, dependencies, code leaks, and all these can happen. And then the build happens. Sometimes in the build also some kind of secrets which is stored. It can lead to some of the vulnerabilities. And then the binaries will be pushed into the artifacts, and then it is pushed into the cloud. So in various phases, the issues can actually happen. I'll pause here for a minute. Any specific questions which creeps in your mind? Maybe people can ask. Okay, we are good. Okay, I'll move on to the next one, which is the real world attack scenarios. So, as I've said, like one such example is the Kasaya ransomware attack, which has happened in 2021. It was because of the some of the controls were actually missing, and the controls can be a variety of controls. It can be the auditing not done properly, or maybe it is done and the team have not implemented it, or most of the ransomware acts happens because of the phishing attempts or any kind of a missed control, I can say. And maybe like I can give you one more scenario as well. Let me give you a scenario on this. Okay, so let me give you a scenario. Yeah, there was an attack which happened in Colonial Pipeline attack in 2021. Okay, so it is all because of the access control and segmentation was missing. And later they found that, okay, the some kind of access controls are missing and segmentation was missing. So, and then in 2023, a Forrester study says that companies with zero trust models, it actually reduced the attack surface by around 70%. They have to enhance the incident response plans. So, and I can say one more scenario wherein, and there was an Optus data breach happened in 2022. It highlighted the need for the faster communication. The solution was we need to simulate breaches to test the readiness. So that's the reason nowadays most of the companies they have a simulation method, phishing attacks, and ransomware simulations. They do it. So it's all. uh, so that's the reason we also have the employee training. So causing the phishing. So how to it shows the importance of the cybersecurity awareness as well. It's all a variety of things. So people have to be aware of. So in the same way, you can also find the real world attack scenarios, the hard coded secrets, or the if you're using like insecure proprietary code, you can come to that. And due to the insider threats, also it can happen. Or any developer who is very hungry is during his notice period, maybe like can add some of the backdoors inside your source code and leave. So that's the reason like many commercial tools, it also checks for the backdoors as well in the source code level. So it checks it on a pattern like once a month, or that's the reason we always say to any dev teams to perform kind of a scan like every 3 months once if you are in agile build. So apart from that, like IAC misconfigurations, it is infrastructure as a code misconfigurations. Lots of things are happening. As I've said, we can use a tool called Kicks, which identifies the vulnerabilities in the early stage itself. And last but not the least, maybe always the vulnerabilities, there will be lots of misconfigurations will be in the running softwares. So it's up to the dev team to fix it as early as possible. So that's the reason we always have a concept called defense in depth, wherein like, okay, during design stage we find, and during the testing phase we find, and maybe in the release stage we find, and once it finishes all these with the first party testing, then it goes, any application goes for a third party testing with an external vendor. We try to find any vulnerabilities in that, and in the network level. So in the various levels we have, so wherein like even if any one of the vulnerability is missed in any one of the stages, it should be identified in at least in any one of the phases. So thereby we make sure the application or the product which we develop is always safe and secure. So the best practices, obviously controlled shift left and shift right strategies, and try to use the software supply chain frameworks like NIST, Mitra framework. And you have to build a strong security culture within the organization. So it's always very helpful for you. So the tools, as I've already said, SemGrep can be used to identify the vulnerabilities in your the first party code, retire.js at the JavaScript level. Kix is a tool which can be used to identify in the infrastructure code. Brakeman is a small plugin which can identify the vulnerabilities in the Ruby source code as well. Maybe if it's useful, people can take a snapshot. So it will be useful in your organization as well. I'll move on with the last slide. These are the emerging commercial tools players which is available in the market. So obviously, if you're into the banking, financial services, or insurance sector, and the customer is ready to pay the money, maybe you always go in for the commercial tools as well. So each and every commercial tool has its own advantages and disadvantages. Maybe like you can use Sneak, Veracode, Checkmarks. Those are the most popular tools. So for static scanning as well. And from the check marks, you have the plugin, as I said, for infrastructure as Kix, KACS. You can start using that. So for each and every environment, you can start using this. Okay, so I've done with the session. So any specific questions in the chat, I'll try to answer now. Or any specific questions you have in your mind, you can shoot your questions now.
Maybe one question from my side. Mohan again. The left and shift right strategy that you mentioned, right? So you explained earlier what functionalities need to be shifted left to make the complete the SSDLC pipeline effective. So the shift right strategy, what components actually, are moving right, if you can make a analysis of these two, or, a summary of this, that would be helpful.
Okay, sure. Shift left is always moving towards the left, right? So it is all moving towards it. Shift right is, even though some companies still they are very reluctant to move it. So it is the older traditional methods only. So after the production, they try to find the vulnerabilities. So some people are very kind of reluctant to move it. So that becomes a shift right. So the older methods only. So it's always advisable for any organization to always move into the shift left. So it's try to find the vulnerabilities earlier in the life cycle.
So if you don't do anything, it is already shift right.
Yeah, it's shift right only. Logically, it's shift right only. But from a broader perspective and for the interest of the organization and from the customers, it's always go into the shift left.
Okay. Maybe just another question. This is
Yeah, go
related
ahead,
to
please.
the AI development, the using AI for code development, integrating with the rest of the tools and the application ecosystem. I know that shift left is, past few years, it's very famous, but then, in the event of AI coding, is there anything specific that you would recommend, as part of the SSDLC and the DevOps? Anything else to be, particularly,
Yeah, okay.
where we need to pay attention? Yeah.
Yeah, correct. So maybe like I will say like some of the companies are started using in the GitLab there is a plugin called as the Copilot. Okay, so it is actually very useful. So you can put that Copilot in so that it makes much easier for the developers. And it helps you. It will be like an AI assistant. It gives you lots of inputs on the source code. I know one of the teams previously they were doing a development for 100 hours. Now it has reduced to like 50, 60 hours after using this Copilot. It has improved the productivity as well. And one more plugin I can give you. Let me check my chat. So it is actually a plugin, as you have asked. as you have asked, related to the AI, right? One is GitHub Copilot, and another one is there is a plugin called DependABot. Okay, let me type it in chat. It is also available in GitHub. Okay, wherein the security reviews can be done by the AI itself. So let me type it here. So DependABot is actually a plugin from the AI which you can put into your pipeline, wherein most of the reviews are done by it, but somehow manual intervention is required by the security consultants. But it is a very useful one, wherein it also reduces the time and reduces the effort. But somehow false positive elimination have to be done by the security consultant. So the AI has given lots of things. So it's up to us, like how we take up those plugins and utilize it in the longer run. So thereby, we try to find the maximum vulnerabilities in the early stages. It answered your question, Mohan.
Yeah, thanks, Pradeep. Yeah.
Okay.
It
Okay. Great.
yeah,
Thanks. Okay, so any more questions? In the interest of time, we have 2 more minutes. Any specific questions? It comes inside your mind. You can shoot it now, or maybe I can type my mail ID, or you can reach out to me in my in LinkedIn, Pradeep Kumar Pondurangan. So you can reach out there if you have any specific questions, anything related to application security, cloud security, or DevSecOps. I am always happy to support you people. So I also support a variety of customers here in Chennai as well, and I support them in the startups. So giving them suggestions, giving them the best particular controls related to this application security, DevSecOps, and cloud security. So I'm always happy to support. So whatever people you have any queries in your organizations or any specific things which you want to learn, I'm happy to support. You can reach out to me in my LinkedIn, Pradeep Kumar Pondurangan. And apart from that, I run a chapter also. If you are interested, you can join. Every alternate months in Chennai, it's an offline meetup that's called as a Null Chennai. It's a cybersecurity meetup. So you can check in our LinkedIn page for Null Chennai. So it is free of cost only. If you are interested, if you are in Chennai, you can come down to. We are going to conduct a session on 18th Jan 2025. So in Chennai, so it will be a good learning session for everyone. It's an offline meetup, so related to the information security space. Okay, I think thanks everyone. It was a wonderful audience. Thanks for all your questions and different queries. It has ignited our mind and lots of questions from everyone. So I hope everyone would have learned a few knowledge about the DevSecOps. So happy learning. Enjoy your day. Thanks everyone. Have a nice morning to everyone.
Thank you, Mr. Pradeep, for sharing your invaluable insights on DevSevOps with us today. Your expertise and real-world examples have provided our audience with a deeper understanding of how to leverage DevSevOps for application security. We appreciate the time you took to engage with our audience and address these questions. Your contribution are truly valued. To our audience, thank you for joining for this interactive session. We hope you find the discussion informative and useful. Thanks, everyone.
Thank you, Mr. Pradeep.
Thank
Thank
you
you,
all.
Mr. Pradeep.
Bye
Thank
bye.
you, Mr.
Thanks,
Thanks,
Pradeep.
Kavita, for
Thank you.
It was
coordinating.
nice to have your
Thank
good
you. Bye.
information. Thank you.
Thank you.